here is my first example using equalities and proof using induction. First of all, notice a lot of things are grayed out here because I'm trying to honestly show you the step-by-step process of how things worked out. I really missed my light board right now where I'd write it out. But anyway, my first step before I even get to the base case, that just that one part's highlighted for right now, or at least showing, is I got to look at the equation. On this one, I have an equation, and my overall goal is going to be my left-hand side is going to equal the right-hand side. So I am going to manipulate both sides of this. That's my game plan for this particular one. Now, not every one I'm going to show this way, just for this one. So in my base, even before I get to my base case, I look at the equation and go, okay, well, there's no exponents, thank God. But there is division, there's some multiplication. So that's the only gotchas that I might have, is I'm going to have some multiplication and division that might come up. So that doesn't sound too bad so far. So we should be okay. Now I do the base case. In the base case, what I'm going to have is I'm going to go ahead and plug in 1, because notice the equation doesn't say anything about n's got to be greater than this or that, so I can use 1. All I'm doing is plugging that 1 into the original equation wherever n shows up, and this is the problem, well, this is the partial solution that I get so far. Notice every spot that I had n, I plugged in 1, and then I go ahead and solve the sucker all the way down to, frankly, well, 4 equals 4 on both sides of that, and that equals our true, because, hey, we found out that 1 works, and that is our base case. By the way, it's also called basis step or something like that in some other books and stuff like that. But anyway, so as long as the base case is true, then we can move on into the rest of our induction step. If this ended up to be false, again, I wouldn't even bother with the rest of it. Just remember that. All right. Here comes the assumptions. In the assumptions, which you're going to see for all of these, if it's true for n equals k, show true now for nk plus 1. I'm also going to assume that right now, because of our base case, I can assume that that 1/2 portion that's highlighted in orange equals that right-hand side of k divided by 2, 3 plus 5k. That's what we've done so far. Now I need to do the show, and in the show I'm going to have that 4 plus 9, blah, 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 plus, and there's my k plus 1 to every spot that I had k, and just the line above it, I'm now adding that k plus 1 in every spot because, hey, I want to prove that these two will end up still being okay. Even though I've added one more, I bet it'll still work out. It might not, by the way, but still. That's what I'm after. Because I am doing a left-hand side equals a right-hand side, I am going to be manipulating both sides so that they will equal one another. If you don't want to do that, you wanted to make one side, maybe this side over here, you wanted to leave alone and then work on the left-hand side, fine, that doesn't bother me. But in this case, it worked out for me personally pretty well. So here's our next step. We just proved that these two items that I'm pointing at right now are good to go. So this whole section that I've got right here, I can substitute it with that k over 2, which honestly should be highlighted, 3 plus 5, plus that new addition of our k plus 1 on both sides, because I just proved it okay for our base case. So I'm going to assume it's okay. So as I'm doing that, I am going to start to reduce things into their forms, as I'll call it. I really haven't done too much on this side yet, but when I get to the factoring, that's where things start getting kind of ugly. So now moving on to the factoring. In the factoring, man, I've had to multiply the k2 into these two. I did my multiplication here. I did my 3 times, 5k plus 1. I combined that into our 8 plus 5k. So notice I'm starting to I'm factoring things out, or I'm multiplying things out here just to get to some common type of form here. And then I do it again with my lowest common denominator for all these. Notice everything's by 2, so I got to multiply everything by 2. This is a lot of work, isn't it? Notice I said division, probably multiplication, and darn if I didn't hit both of those. So, and fractions. I should have put fractions on the list, although, you know what? Oh, no, there was a fraction. So notice how I instantly, as soon as I looked at the problem, I kind of knew what items were coming up. The problem really gives you a dead giveaway of what items you got to remember here and how to get this done. Now again, my whole thing that I'm just trying to do here, I'm just trying to get it to common like terms, just so frankly I can get down to this level right here and say, okay, now I can breathe. How the heck do I get both sides to match one another? That's all I'm after, and both the right-hand side and the left-hand side have to match. So I'm manipulating, again, both sides. After I have this cluster of, well, items here, I actually can do a lot of things with just simple math because I've done all the work of lowest common denominator. I've factored things out. I've reduced some items. Now that I've put it in this simple form, I can actually, I'll be darned, I go ahead and match the left-hand side and the right-hand side just by taking values that I've seen before. Oh, there's 5K, that's gone. I can get rid of that 5K, or 5K squared. I can take out some of the 5K over here, and that's 10K over there. I can take, well, there's a 3K. So notice I'm adding some things together here in order to get both sides to go ahead and match. Whew. Yes, it is a lot of work, and yes, I'm hoping that I'm going over this slowly enough to make sure that you understand what my thought process is on getting some of the things done. So that's what I'm hoping for all of this. Once I find out that both sides that I've messed with are equal, then I have my therefore, and then basically I repeat the question here that 5K minus 1, 5K, minus 1, I'd like to rather have the parentheses out there, does equal our n over 2 of 3 plus 5n. A lot of work, but I'm hoping again you understand the steps that I have in there. If you don't, let me know. But we're not done yet by a far shot.